Hello, everyone. Hey, Patricia's here.
Hello, good morning.
Morning. John's here. Wow.
Wow.
John's not traveling. John's not in some
Somewhere. No, I travel later on today.
There you go. I knew that was going to happen eventually. Oh, Majid is here. Majid, I haven't seen you in these meetings in a long time.
Yes, hi. Too many traveling occasions.
Yeah. Well, thank you. Welcome back. Patricia, we usually wait till about 8:03 or 8:04.
Oh, okay.
Just to get a decent number of people.
Okay. So I don't know if I logged in, I joined the Zoom meeting with the link that was in the wiki. And I don't know if it is updated to the one that is in the website. Sorry, to the one that is in the calendar. So
Oh, I see.
I would just double check that because yeah.
I think it is. I joined from the calendar.
I joined from the calendar, yeah, but when I tried to join from the wiki, I was the only one in that room.
Oh, was it a different? Oh, I see. Okay.
Yeah,
we will check that. Thank you so much.
Yeah.
Okay. Wait another minute or two, and then we can get started. I also see we have some newer people on the call, so we should probably do a few introductions for the new folks once we're done with most of the agenda for the day. I'll say this now, but I'll forget it by the time we meet.
And looks like Supernormal's back.
Yeah, well, that's a constant companion now, John. I haven't gone to look at these notes because I honestly don't know where they are. But today I got a notification saying the meeting summary for some meeting could not be generated due to insufficient transcript. So I'm wondering if that's just, well, I don't know if that's the supernormal or not. We'll have to find out. Okay, so I think we've got a quorum. We've got the folks who are presenting here today. So welcome everyone to the 8 a.m. call for the Open Chiplet Economy group. Today we are very excited to have Patricia and the co-leads from the HPC and AI modularity workstream. It is a new workstream that we are planning to start. It's based on some prior work that was done with John Fschall. And Patricia is going to present the scope and the goals and also try to figure out a time. She has an idea of when she should have these meetings, but we'd love participation and to get the word around and ask questions. This is where all the interest and the directionality is set. So it's all yours, Patricia. Hopefully you can share your screen.
Yeah, let me try to do that. Slideshow.
Yep,
Okay.
we see it. Perfect.
Okay. Let me get this out of the way. Okay. All right, so well, thank you so much for joining today. Basically, we want to launch this work stream in HPC and AI modularity. George and I worked on these slides with input from Anu and a lot more people that were helping us with bringing up this new work stream. Can you guys hear me well?
Yes, I can hear you.
Okay, great. Okay. All right, so a little bit about me. So I'm a research scientist at Lawrence Berkeley National Lab. I put this picture because one of my favorite things of going to the office when I go there is the view. So if you guys have a chance to visit, it is worth the view. I'm passionate about ASIC, SoC, digital and mixed signal design. I've worked with ultra-low power IoT, non-conventional computing paradigms such as stochastic computing. Of course, now I'm involved in high-performance computing. And one of the biggest things that I really like to do is hardware accelerations. And that's why I got involved. That's why I get attracted, naturally attracted to chiplets. Okay, so just to give you a motivation, we see that performance has, like for 10 years, performance improvement was really good for an average 1,000 times per year. And then we see how it kind of dramatically this it stops increasing and is kind of dramatic, right? So to the point that by today we don't have any increment in HPC at all. And yes, so we know that the problem, like one of the problems is scaling, is the problem that we cannot scale the transistor beyond 3 nanometers. But there are other problems that we have been facing along the last years, and those are, for example, the power wall, the fact that we cannot increase the power consumption in our cabinets because then we will see things maybe turning on fire. We also know that as we reduce as we do scaling in transistors, we don't do the scaling at the same time in the interconnection and the I/O. And that was not a problem before, but suddenly we started to see that interconnection and I/O were significantly contributing to the problem of scaling, to the point that now we have very powerful computing units sitting idle, waiting for data to traverse all the memory hierarchy to get to the computing units. And that's what we see as the memory wall. And then, well, the fact that we cannot scale the transistors anymore, right? So with all these combinations of issues that we've seen in HPC, we are getting this block and where we cannot increase the performance as the computing performance as we used to do. Now that's for HPC, but for AI, something is we have a very similar problem, and we know that AI is super important these days because it's basically permeated every single aspect of our lives. And if I equate computing performance with power or energy consumption, you can see that before artificial intelligence became a thing, we expected doubling energy consumption every 3 years. But now we expect power consumption to double every 3 months. So you can see that we are actually, facing a dramatic need for a lot more computing performance. So we would say, okay, we have reached the exascale and we can do very wonderful things with HPC, with computing. But the problem is that today's applications demand more performance. And there are applications that are that are important for the economy, such as the semiconductor industry or aerospace, automotive. But then there are other applications that are vital for our survival, I would say, such as things like weather modeling, energy generation and distribution, epidemiology, vaccine generation. So all these things all these sciences are important for how we face the future as a society. So we do need these needs for more performance. So I love this slide that I borrowed from John Shelf because it's a really clever parallel between the way computers evolve with the way nature evolved. So basically what John says is nature's way of extracting more performance is in a resource limited environment is specialization. So here we see that we, like at the very beginning of the times, we have a very, very powerful, we tended to build very powerful general purpose machines. But then when we were in the post-Denar era, we turned toward many lighter weight processors, and then what we know like parallel computing. And now when we are, what we call the post-more scarcity era, where we cannot scale the transistor anymore, what big companies such as Apple, Google, and Amazon are looking into is a specialization. So we have these units that are very good at getting the resources of the environment, right? So these are examples of specialization as we see them today. So here we see, for example, the Apple architecture with around 40 specialized blocks. And in the other hand is how Facebook is looking at modern computation. So in the early stages, we had like a one fits all solution with the CPU. But when we go to modern computation, you can see that we're going to have a piece of hardware that is specialized for each of these different applications that we're going to see. So the question is how this is going to help us in HPC and artificial intelligence, right? So, and the thing is that as good as it sounds, specialization has its own integration challenges, right? So if we want to envision a system where we combine CPUs, GPUs, and specialized accelerators implemented in ASIC, FPGAs, CGRAs, we have to figure out how we're going to integrate them all together, how data is going to move around things, how are we going to do the control flow complexity. And I think that's when chiplets are quite interesting to solve all these integration problems. So we have these very powerful specialized machines, and then using chiplets, we can put them on the same package. So I don't think I need to explain to this crowd what a chiplet is, so I'm going to skip this part. But I'm going to give you a thought experiment of how we see this working. So let's say that we start with a monolithic SoC, and we use the John Schalf and Bapi Vinakota use the Fugaku architecture as an example. Where you see here, this is the SoC, all but with all the pieces all integrated together in the SoC, and here we have the architecture, and then they kind of extracted, or they got all the specifications of the architecture, including die size and power consumption, nodes in the system, all these different things that matter when we're building these chips. And then the step 2 would be, how can we map each of these functions to an individual chiplet, right? So we have, of course, the CPU, right? And that we can place it on a single chip, but we can also have the PCIe IO chiplet, which is something that is necessary, but not necessarily the most interesting thing to design. We have the TOFU chiplet. We have, that is the network on chip interconnect. We have another chiplet for the interface between the HBM and the processing units. And then we can take all these smaller chiplets, or all these very good, well-designed, specialized chiplets, and then put them together to build the Fugaku architecture on a single package. And then we can, like this is kind of a hypothetical example of how these all the specifications that we will have to set to build all these little chiplets. But what is more interesting about this is the fact that we can place these accelerators that we were talking about, that would be the result of a specialization, next to these computing units in many different ways. And that's when modularization come into play. So basically in this work stream, we will make the case for and specify standardized chiplet form factors to effectively deliver specialization and heterogeneity for HPC and artificial intelligence. We know that these can solve the integration challenges in the way that I just described. We start from the monolithic SoC, we get all the modularized chiplets that we can place to build the full system. And then we can, of course, we're going to need to leverage all the advanced packaging heterogeneous integration that we have available, or figure out how to use them in a clever way. So one key thing is that, we know artificial intelligence is a clear market, so I don't have to argue that because that's something that is clear. But then for HPC, up to certain years ago, it was considered a niche market. So what we want to show here is that it's not a niche market anymore. So we can see how it is bringing a lot of money, and it's a market that is becoming extremely important in the computing market. Okay, so the high level goals that we have in the work stream is to develop open standards, that is the integration of chiplets from multiple vendors into future systems, and thus also support reusability of hardware IP for HPC and AI applications. So basically, if we need an interface between the HBM and the CPU, we don't have to develop it ourselves, or trying to get an IP that is extremely expensive. We can just get the chiplet to be integrated next to our computing units and part of our system. And then we want to suggest technologies that support modularity and accelerate scientific and artificial intelligence workloads, such that we can deliver the performance growth that we were used to before we hit the post-Moore era and post-Dennard era. And these all targeting scientific and artificial intelligence applications. So basically what we want to do is provide a path to achieve modularity for artificial intelligence and scientific applications. And as I said, the idea is that we can build all this ecosystem that is necessary, that we show here on the left, and we can have clarity about what the die-to-die protocols would look like, or should look in order to make this a reality. The die-to-die bandwidth, packaging technology, power delivery, thermal and mechanical stress, firmware applications, and software. So these are just examples. And of course, we're looking into what other things do we need to make sure that we make this a product that can become reality. So we have two phases, and in the two phases, in the first phase, we basically are going to identify the compute kernels and all the requirements around them in order to build specialized chiplets. So we have the CPUs and we have the GPUs, but what those specialized hardware accelerator that we're going to place in chiplets would look like. So here an example is, for example, a density functional theory chiplet. Because we know that density functional theory takes up to 25% of the Department of Energy workload. So it's a really good candidate for specialization. And for example, we know that to build density functional theory, we understand that at least 90% of the logic would be devoted to calculate fast Fourier transform, and also the majority of the computing time goes into fast Fourier transform, right? So if we want to build a chiplet with for density functional theory, it for sure will need a big three-dimensional fast Fourier transform to accelerate this. We have found that if we use the FFT hardware accelerator right, and we figure out how to move data efficiently, we can get 50 times to 100 times faster computing or better performance than comparing with a GPU, which is a lot. The second phase would be to identify. So now we have the accelerators, we have the kernels, we know the chiplets that we need to build. We're going to try to figure out what are the supporting technologies and standards to make sure that we can actually place those chiplets on the same substrate and on the same package, and that they can actually effectively communicate and move data and control information and control the flow of information through the different chiplets in a very efficient and way to such that we can actually get the performance growth that we're looking into, that we need when we think about these diverse heterogeneous systems. So at the end of the day, I think the most powerful thing that we want to do is that if we have all these little chiplets, we can create a family of different products, right? So in this example, we have the baseline architecture, where we basically build with chiplets the Fugaku architecture as it was. But then once we have everything, kind of when we have identified all the chiplets and all the components that we need for this, we can build different systems, right? So we can, for example, replace the CPUs with FPGAs to build programmable accelerators. On the other hand, we can have a RISC-V, a sea of cores, of RISC-V cores. For example, here we're saying 256, and we can also have an inference engine, that basically a tensor processing unit or a neural processing unit to accelerate artificial intelligence and place it right next to the CPU cores that we had before. And then we can also have the future accelerators that we are thinking of coming from specialization. And these future accelerators will be compliant to size, power, and the thermal requirements that we defined, such that it is extremely easy to place them next to the logic, in spite of being so specialized for what we want, or for the application that we're looking at. So this is actually very powerful. You can see that we can mix and match. So in some places we have HBM, in others we have DDR. We can have different networks on chip, depending on what we want to do, depending on the efficiency or the characteristic that we want to optimize in the particular family that we're looking at. And all this will be possible by the standards that we want to create in order to make sure that we guarantee interoperability. So we need your input. We really want everyone to participate. We want everyone to give us their thoughts about this. Basically, what we want to do is, I'm Patricia. We have also George Michelogyanakis and Anthony Gutierrez. What we want to do is basically facilitate that the way that we all get together to build this economy of chiplets. So here are our OCP emails. If you have any question, or you're not sure how to participate, or if you want to, tell us your thoughts about this. Our first meeting is going to be in June 11, or this is the tentative meeting. If there is another time that works for the majority of people that wants to join, we can figure out a way to find a better timing. But for now, our first meeting is going to be June 11, and we're going to have bi-weekly meetings every Tuesday at 9 a.m. Pacific time. So how to participate? So basically, you want to subscribe to the project mailing list. So we can have a communication. You want to add the project meeting to your calendar and join the conversation. So here is the QR code where if you go to that link, you can see the subscribe link for the mailing list. Yeah, so I think that's it from me. We started the wiki for the HPC and AI modularity. And then you can see that here is how you subscribe to the group. Just send an email to that mailing list, and it's very easy. We're gonna be filling this with interesting information as we get to the meetings and as we build the conversation and the groups. Then the calendar, and then, this is the same calendar. And the other thing I wanted to show was, I think I missed it, but basically, if you go to the yeah. We are here as well. So here is the list of active work stream. And here is our entry. Here is the calling to participate in the meeting. And the the points of contact for the work stream. Yeah, so that would be it from me.
Thank you, Patricia. As you can all tell, Patricia is extremely organized. She's got her wiki page up. She's got the links. She's got everything in order. So anyone with interest, please reach out to her. Patricia, could you go back to the slide that showed the FFT case that you had, the fast Fourier transform, if you
Yeah.
don't mind?
Yeah, of course.
I just had a quick question there.
Yeah, like if you have questions. Yeah, I forgot to say that, but please bring up.
So I think on this one, what you're saying is that today what you use is you use generic GPUs or some combination of smart chips that do this FFT, but it's not optimized for FFT. So the latencies and the efficiency of the algorithm is not captured in the way you do it. And what you'd like to see is a chip specialized to do FFT, because 25% of your workload is running these FFT algorithms. Am I capturing that right? So you don't have that now, but that would be the first sort of use case you're looking at for this work stream.
Yeah, this is a good yeah, so this would be one of the, this is just one example of how we can go about it, but you're right. So basically 25% of the DOE workload is density functional theory. And this is an example from the scientific from the HPC scientific computing perspective. There are there are a bunch of other examples that apply for example, the artificial intelligence side of things. But yeah, in this particular case, so if we focus on this one, we have density functional theory, 25% of the DOE workload, which is very interesting. So that makes it very interesting and creates a market for it. And then basically what we're saying is that if I don't have slides for that here, and I do have them in our presentation, but yeah, I'm not gonna read that, maybe I don't find it, but basically what we do is that we have the density functional theory, total implementation. There are a bunch of codes for it, and those codes are optimized for CPUs, and there are some other newer codes that are mapped to GPUs, right? And they have, of course, impressive performance. So not to say that they're
of course.
impressive, but then what we can do is actually get we can identify the different kernels. So when we do that experiment, we're gonna see that FFT, for example, takes up the majority of the time. This is a three-dimensional fast Fourier transform. And then there are others that will come, other kernels as part of the density functional theory that would come up. So let's say that if we want to run, density functional theory, if we want to run it for more time, or we want to increase the number of atoms that we can model, and that would be the ideal. We're gonna have, what we can do is map this FFT kernel and all the other kernels that take the majority of the time for density functional theory, map them to specialized accelerators, right? So basically hardware accelerators that can be implemented as ASIC, or can be implemented as FPGAs or CGRAs, for example, as well. And then if we do this, instead of sending, like when we need to calculate the three-dimensional FFT, it won't go to the CPU or the GPU or the parallel C, of course. It will go directly to a hardware accelerator.
Right.
And this hardware accelerator is what we're going to map to a chiplet, depending on the form factor. And then that's when we see, or we project that we're going to see at least, only for the FFT, at 50 to 100 times faster execution times. So now imagine that if we do that for more kernels, for more of the kernels that make up all the density functional theory algorithm.
Yeah. Yep. No, that makes sense. Thank you. I appreciate that explanation.
I appreciate a very, very quick question. I just joined, but that's very, very interesting. You're saying you get 128 times faster than, say, running it on a regular GPU with...
Yeah. That's based on the previous experiments that we have run. Yeah, this is compared with that GPU. And this is basically because we are able to map the data flow to specialized hardware. So specialized hardware, and we also kind of optimize the way we move data or data move across the specialized hardware. So yeah.
Oh, very thank you.
I don't know if there is any other question.
Yeah, I have one question. It's more of a some comments and thoughts on one of the slides that you mentioned John had presented, where there is biological evolution, kind of going from these high performance computers down to many lighter weight. And then you had previously also mentioned that right now, with this whole AI brute force craze, we have power going up every 3 months by a factor of 2, right?
Mm-hmm.
So one big question that comes to mind is, okay, chiplets can do this much, right? We can optimize pieces of silicon and piece them together. What else do you think is needed fundamentally to solve some of these challenges?
That is a good question. So we have part of the work stream, part of the idea of creating this work stream is getting input about what else would be needed. But basically, we think that we do need to work into the packaging technology. That's something that is, like I know, like as packaging technology gets a little bit more fancy, we're gonna have thermal limitations and mechanical limitations that we really need to address. We have to figure out the power delivery. So that's something that I think is not an easy feat, given that we're gonna have everything distributed. The integration of the chips, that's something that is quite an interesting thing to look at, because what we're gonna see is what is the best interface for the dice to communicate, and that's gonna be something that is going to affect all the chiplets, right? So that's like a solution that has to be a one solution that fits them all, and in general, when we try to do that, we do compromise performance. We have also the portability idea. When you talk with HPC and artificial intelligence developers, both of them, like especially let's say the artificial intelligence developers, they looked into they basically don't go beyond Python sometimes. So how do we make sure that even though we have these specialized accelerators, they are still going to be able to code in the same way, in the easy way that they do when they do use their Python and their Jupyter Notebook things. And the same thing goes for the HPC. There are so many frameworks out there. How do we make sure that those frameworks or those software solutions that we have that span from Julia, C++, Fortran, like all these different things, MD, GPUs, all these different scenarios are going to be easily transferable. So I think we have to figure out how do we develop this economy, and how we make this transition. But it's quite interesting challenges. So I don't know if George and Tony, do you guys want to say something else about the question?
I think you answered it very well. There are many things that need to happen to make this easy and approachable, and really that's the goal here. So that's a question we're going to be trying to answer throughout the work stream. I don't think we can answer it now.
How big are your dies? Roughly, the dies you're trying to connect.
Yeah, that's actually exactly the questions that we want to answer. So when Bapi and John did the exercise to figure out how the Fugaku architecture would look like if we chipletize, they did an educated guess. But that's exactly a question that we want to answer: how big these chips would look like, or these chiplets would look like, in order to make this feasible. So yeah, so I think you're on the right track. You need to join our meetings.
I probably will. I'll look it up. Patricia, you don't recall that estimate, right? Like that guesstimate or something.
Let me take a look. I think I have it in the slides, but
We arbitrarily picked 11 by 11 millimeters.
11 by 11, yeah.
I was gonna say it was a 10 by 10 from recollection, John, I was
Yeah,
frantically searching the previous work.
yeah. It was 10 by 10 and then plus another millimeter, for spare change.
Okay, thank you.
Yeah, so if there are not more questions, I can give the floor back to Anu, but if something come up, please email us. I'm gonna put the slides soon in the wiki page, and there you can find our OCP emails. And I don't know if you guys had the time to scan the QR code to get the coordinates, but if not, I'm going to very quickly share it again so you guys can scan the QR code. But yeah, so that will be it from me.
So Anshu has a question on the chat. Are you looking at HPC AI applications only or things beyond that like automotive?
That's a good question. So far we have only discussed HPC, scientific computing, and artificial intelligence. But I don't know if I think if we have an automotive expert that would join, we can talk about it and see if it fits.
Yeah, I think, Anshu, the way we're looking at it is HPC AI is the need of the hour right now. It's the right time to jump into it. We're absolutely clear that this area benefits from the chiplet technology, that we need as much compute as we can, we need as much cooling as we can, and we need it now. And so I think it's the first, the best place to start with. The automotive guys, as you can tell, it's catching on. They're trying to figure out how to get this to. I had a conversation with IMEC last week. How to expand chiplets to beyond just ADAS systems, which is ADAS is basically a computer system. And so I think it's a matter of time. And so I think if we get our teeth sunk into this one and have some really good ideas of how to attack these little problems that we have, which can give us great savings and advances, we can apply those same principles to automotive as it ramps up. That's my take on it.
Yeah. My question
Thank
on
you.
that, like maybe a quick one, if you don't mind. You're thinking of other things like, matrix manipulation. That's almost everywhere in automotive, in all AI algorithms, like get more, better matrix multiplication, inversion, that kind of stuff, or just FFT. You're looking at the FFT primarily.
Yeah, I think FFT was just one example of how we could identify those kernels. So it was just one example, but you're right. For example, matrix vector multiplication is something that is, the bread and butter for artificial intelligence. So
Yeah.
for sure it will come up. And for example, a sparse matrix vector multiplier and sparse matrix multiplier will come up in scientific applications and artificial intelligence, both. Things like graph neural networks will definitely come up in both in artificial intelligence and scientific computing. So maybe randomized algorithms will be key to make these chips more efficient as well. So and those randomized algorithms is something that comes in both scientific and AI. So I do see a bunch of kernels and algorithms to come up as part of the work stream.
That's very good. Thank you. That's really good. Thank you.
So the time that Patricia had put up was a Tuesday meeting time. We want to make sure we get the most interest and the most number of participants. So if you're interested, that time absolutely doesn't work out for you, let us know. There's ways of contacting her, me, Jawad, and we can figure out a time, because I think we'd really like to. I mean, this is a really great area, and some work has already gone into it. We'd really like to see this come up with some really clever ideas, which are helpful to the industry and make sense in generically across the world of HPC and AI. So please let us know your interest.
What time were you thinking on Tuesday, Henry?
9 a.m. 9 a.m. Pacific time.
Okay, good.
Yeah.
That's just after the OCP HPC call. So.
And it's bi-weekly.
Yeah,
Right.
it's
Quite frankly, I can see potential benefit not only for what you're doing, the accelerator, but even for GPUs. Like if you find a way how to make matrix multiplication, say, more power efficient. That's something everyone wants to do, right? Whether it's on the chiplet or on the accelerator or GPU, or so I can see the applicability. So you're starting next week, by the way?
Yes, it's June 11. Our first meeting will be June 11.
Okay, very good. Thank you.
okay. Please do join.
Yeah, I will, not next week, but I will join maybe the week
Okay.
after. So,
Yeah,
thanks.
I think it would be good if you just sent a note to Patricia expressing interest, so we at least know the time that works and the number of people.
Okay,
and
your email is, I think I'll find
it's all
you.
on the website. So the wiki page she showed, if you just go to the OCP
Okay.
wiki page, all the information is there. You should be able to get that.
We'll do that. We'll do that. Thanks.
Yeah.
Thank you.
Thank you. Any other questions for Patricia and team? Okay, I guess not. If anything else comes up, please email. Patricia, thank you so much. That was a really nice presentation, well thought out, organized, and great job. Really appreciate it. And I'm very excited about this work stream. We've been talking to Bapi about this Bapi and John about it for a long time, I think over a year or two ago, with a whole bunch of industry folks. I think this discussion started at a Chiplet Summit last year. And then it's morphed into this, and so it very cool stuff. Thank you so much.
Thank you. And yeah, I'm very excited about it and to start working with all the people that are also excited about the same idea. So please do come to the meeting. Yeah.
Yep, thank you. John, you were
Anu,
going to
is the
say
recording
something?
going to be available? Is the recording going to be available, Anu? I missed the first bit.
Is it the recording? And
For
yeah,
this
so,
meeting?
Yeah.
Oh yeah, I should be able to send that to you. Yeah.
Okay, thanks.
Yeah, if I don't send it to you by end of the day, Alan, just ping me again.
All
I
right.
make a note. Yeah.
Thanks, Anu.
You're welcome. John, you unmuted for a second.
Yeah, thank you, Patricia. That was fantastic. and thanks, George and Tony.
Yes. Okay, so that was the main agenda for today. The other pieces I have are Global Summit, guys. There is a deadline for submissions. We would really like to, I think Jawad and I were discussing, and we'll reach out to the individuals who we think we would like to see some work. A business work group for sure. Marek, you're on the hook. Jawad, is there anything you'd like to add here?
Well, so I went over to CDX folks and I reminded them because I think their work is quite interesting. I think business work group, the workshop and some of that stuff that we did a few weeks ago is very interesting. And obviously everyone wants to know about die to die. Then we have this new exciting work, which is HPC modularity and some other things. So I was thinking maybe what we should do, Anu, come up with like 3 or 4 sections that we can propose. So the proposals are due in 2 different areas. One is this 3-hour workshop that we want to do there, and the other one is Innovation Village, where we would like to have some demonstrations. So people who did demonstration last year, we probably need to talk to them and get their proposals in. So I'm open to discussion. My first request to the CDX and ADK and MDK work group was for folks to turn in proposals. And then, once we have the proposals, we can maybe change them slightly, maybe make a panel, a internal panel and an external panel. So internal panel might be more like short talks. So we can compare and contrast what's going on within OCP and, what is the state of the art in the industry. So that was the thinking that I had, but I'm willing to discuss that here and get feedback from everybody.
Yeah, I think we need to, maybe we need to start, like you said, you've already reached out to CDX guys. I'll reach out to Marek today. And then we have Patricia. So yeah, I think we just need to draw out on a paper what are the topics, what are the potential panels, and then who can we invite. Cliff and I were trying to get the IMEC guys. They seem to have every conflict, unfortunately, known to mankind at the same time. But I'm going to ping them again today and see if they'd be willing to give us a talk on their thoughts, because their thoughts line up very similarly to what we have, and definitely automotive, as someone asked, that's really the place to get to next after the HPCAI, and IMEC seems to be tackling that with a lot of the tier 1 and tier 2 automotive guys. So we'll try to get that. So just everyone remember the deadline is around the corner, unfortunately, June 21st. Right, Cliff? Well, I'm just going to say June 21st.
So this is Kevin. Hey, you're right about the deadline.
Okay.
As far as topics, if we're going to be publishing an update, about 2.1,
Yeah.
that seems like that would be fit
Yeah.
into the one of the 4, I think Joab was saying 3 or 4 sort of blocks of
Right.
topics.
Yeah.
That's
So,
one of them.
right. When he said die to die, I think that's right, Javad. That's what you
he
meant, right?
Yeah.
Yeah, exactly. Right. So
Yeah. So that would be one, Kevin. So we will definitely reach out to you and Elad for, we're trying to include and, Cash's ideas for Cash was on the
For
meeting.
IoT.
But yeah, IoT and Wirebond, and sort of see where we can take that to the next level for sure.
That's great. And then, Jawad, you said there's going to be an innovation center as well, so that, like demos and stuff.
yes, we did that last year. Kevin, were you part of it?
Yes, I was.
Okay, you need to please submit a proposal. You should have received a email from Kate Handel on how to turn in proposals for Innovation Village. If you didn't, let me know.
I have a lot of emails, so let
Okay.
me look for it.
Uh,
I'll check.
Yeah.
Thanks.
Okay. I think David, yes, David's on the call. David and Tony are planning. So maybe
David was right next to me last year. That's where I met him. So are you planning another demo this year, David?
Yes, definitely. We are. So last year we were demoing kind of the initial stages of a design that demonstrates the CDX, the design kits and workflows. And this year we have continued work on that, so we'll expand on that and just have a more how do I say, improved demo with more stuff in it that relates to CDX. That's kind of the overall idea.
Sounds great.
Okay, so that's important. That's looming over our heads. At least we need to get the ideas and the abstracts in. So I think Jawad's outlined the categories that we're interested in putting together, panels or talks or whatever it may be. If anyone has other ideas, please do reach out to us. As you can tell, sooner the better. We are really around the corner from this deadline.
Yeah. So Anu, before I forget, I think since this HPC work stream is just starting, we probably need to help them turn in a proposal for global summit so we have a slot for them.
Yeah.
I think it's going to become very interesting by that time frame. That's what I'm thinking. Yeah.
Yeah, no, I absolutely. We will work, we'll help the work stream put together a proposal. Okay, the last thing I had, if Cliff is on the call, Cliff, do we have a finalized list of speakers for the June 14th and June 21st workshops?
Yes, actually, we do. Except there may be one or two changes based on a call we're having with, I think later today. But we do have a very near finalized list. It's already at the website on the upcoming.
Okay. I didn't realize it was on the website. Sorry.
Yeah, the website has been updated and the spreadsheet we're using internally has been updated.
Okay.
And I think it was for David and James to send an email to all the speakers now with the current schedule, making sure they know when they're speaking and sharing the template with them to make sure they have the template.
Right, I don't see James in the call. David, do you know if the speakers have been informed of their time slots?
I do not. I'll sync up with James today and find out.
Yeah, I think at least for the June 7th speakers would be a good idea to get that email out today because that's a
Yes.
sort of a week notice. And then the one on June 21st can get a little break. There's going to be quite a bit of audience, I know, because you know, Cliff, because we are co-doing this, or collaborating with JDEC, JDEC has sent out a lot of mails, and I'm getting emails from folks saying, hey, JDEC has this thing with OCP. And I'm like, well, yes, I know about it. So there's a lot of people who are going to sign up for this. So one thing they're asking me is a list of speakers. So now I can point them to the site and say, it's almost final, right? There could be one or two changes. That's what you're saying, Cliff.
Correct. It's 97% fine.
So
Okay.
Cliff, here is an opportunity to advertise. Can you please put the link to the website so everybody here copies and posts on their LinkedIn?
The link here in the chat on this call.
Yeah, or if you also have a LinkedIn advertisement, we can go and like that.
I have to go look for that one too. We probably did a social media push. We did more than one, I think. Just a minute. Let me.
I saw it on LinkedIn for sure.
Yeah, I already pushed it on LinkedIn on my side. But
I'm sure we did as well from the OCP.
We have 20 people here. We can make use of.
Just a minute. Give me a minute. I will look for the link.
Yeah. No worry. I think, yeah, okay. No, that sounds good. So for everyone on the call, June, the next Friday's call and the one after that is going to be extended. So it's going to be over 2 hours, just like Marek had for his business workshops 2 months ago. And so there's not going to be regular meeting, but it's going to be an extended time. It will all be recorded anyway, so you can listen to it afterwards, but it would be great to have active participation and questions. So.
So I know Cliff is looking for the LinkedIn, but can you also place the link here in the chat?
I'm looking for.
Yeah, I think he's looking for the link.
While I'm looking for it, did we talk about the Experience Innovation Village?
We touched upon it, and people should have received the email from OCP to turn in proposals for Innovation Village, but we did talk to Kevin and David and Tony here. Was there anybody else on the call here who was part of Innovation Village last year?
Just to say that the call for Innovation Village stations is open, and I think we need to, Anu, Jawad, let's try to coordinate something for the open chiplet economy.
Okay.
Yeah, Jawad, to your earlier question, I have the general call for, papers. I don't see anything about the Innovation Village in emails or who to contact. So if you or new could shoot me a note, I would be happy to respond to that person.
Well, Kevin, the Innovation Village, there's two things, right? To be clear, abstracts for speaking in the open chiplet economy half-day session that I hope we'll be able to pull together. We need submission of individual abstracts, and that's in the call for papers.
Yeah.
The Innovation Village would be a proposal put in by Anu and Jawad, which covers all the stations that we want to display. So there'll be one proposal. There should be one proposal that goes in as a group. If you put it in, if you want to put something in separately, we'll combine it.
Yeah, no, I don't want to be separate. So I'm just trying to. Jawad had said we would have received a separate email to reply to for that, and I'm not saying I didn't get it. I'm saying I can't find it. So
it would have
if
been,
I did,
it wouldn't have been an email. I don't think it would have been on the. It went out on social media that the call for participation in the Innovation Village is open. And it also went out in the OCP mailing list. But you wouldn't have received a personal email. You would have received the monthly newsletter from OCP.
Oh, it must be that then that I looked at. Yeah.
Okay, everyone, I just put the link to the 3D packaging workshop in the chat. So that's the information and with the speaker list for everyone to share. And that link has already been shared with JEDEC, by the way. So hopefully they've been able to promote it.
Yeah, I actually just came from the JEDEC committee meetings, and they are promoting this. I have not actually, like Anu said, I haven't seen it from OCP, but I've definitely gotten contacted by JEDEC to register. So they're trying to drum up support, which is great.
Which is great, and we put it in our mailing So if you're not reading the newsletter, that would be why you haven't seen it, because it's in the newsletter and it's on social media.
Okay. Thank you for that. So, Patricia, you have the link now, and it would be good to advertise the list of speakers because people kind of get excited when they see some important people there. So, I wanted to actually, before we finish, ask if there were any new people on this call today and if they could just introduce themselves, but I think some of the new people might have already left the call. But if there's anybody here who doesn't usually on this call and wants to say hello, please do. Some of the folks from LBNL, it would be great. Yes.
Hi, I may say hello then. I'm Angelos Ioannou from John Sal's team. So I'll be joining the very interesting meetings from now on. I'm computer science engineer with a big background in FPGAs and parallel computing and acceleration. So happy to join forces.
Γεια σου.
Thank you so much.
Καλώς ήρθες.
Nick, is there anyone else who wants to go?
No, I was just saying hello to him in Greek.
Oh, you say
Yeah.
hello, which of course I didn't understand.
No, I understand. No. Γεια σου. Χάρηκα που σε γνώρισα.
Oh, ευχαριστώ πολύ. Thank you very much.
Kalimera is all I know. Kalispera and Kalimera. So.
Yeah, Anu?
Yeah. Oh,
Yeah,
hey,
sorry,
Raghu.
hey, sorry, I'm coming to this meeting for the first time, but I think you've seen me in the Marex meeting that's right next to
Yes.
this. So I think I like Luisa's presentation, and so I'll try to join the HPC, and maybe I'll try to come more and more for this meeting as well. So a lot of good things
Yes.
happening out here. I think just a quick background, people who are not heard about me. I've been in the industry. Now I'm an entrepreneur looking at new things to do. But before that, I was in product management and engineering at Dell and Intel. And I've done like a lot of the workloads for like HPC, markets for HPC and AI ML. So it's kind of a lot of interesting things that, and I also was in the engineering group at Alpha Risk. So I got some of the chip background also. So I'm kind of eager to see what I can contribute out here.
Well, thank you so much for joining us, and please do come to more meetings, Raghu. It's nice to have voices of reason from different parts of the industry. So we because we're not all saying the same thing and patting each other on the back and saying we're correct, but we need voices of reason because this is a whole ecosystem, not just chips or it involves everybody. So thank you so much,
for
everyone.
that welcome. Yeah, thank you for welcome, Anual.
Absolutely. We are 2 minutes over. Thank you, everybody. Look forward to seeing you at the workshop next Friday. Bye.
Thank you. Bye.